sec squared x tan to the 12x plus tan to the 14x dx. So we have sec squared times powers of tan. Exactly what we want. Right? So integrating will get 1 over 13 tan to the 13x plus 1 over 15 tan to the 15x plus c. Right? Now again, this method will work for any expression as long as you have an even power of sec. Right? So if you have an even power of sec, in other words, you have an integral sec to the 2k tan to the nx, you replace the sec squared, you save one factor sec squared x, and what you're left with is sec squared x to the k minus 1. Right? And this is then 1 plus tan squared x. Right? So this technique will work whenever you have an even power of sec. So we looked at two cases where we have integrals involving powers of sec.